Right, so they want us to use superimposition to find the current going through R1. So that's current here. So superimposition basically says of one source, see how the on source interacts with what you're looking for, then of the other one, vice versa. So let's start. Let us off the current source 5 milliamps. Now to off a current source, you simply open circuit it. So if I'm to redraw the circuit, it will look something like this. Not something. Now I can use mesh analysis to solve this, put the current loop here, put the current loop here, find the current and all of that. But honestly, I'll just first use a shorter method. This is a voltage dividing circuit. So as you know, this whatever is here is in parallel with whatever is here. That's this point and this point. And for circuits in parallel, they have the same voltage. So whatever voltage you have in this particular circuit is the same voltage you have in this circuit. 8 volts, 8 volts. So since we know the voltage here, we can simply just use um Ohm's law. We know the voltage here, V then over R. So it's going to be 8 volts over what are the resistors there? Because the current here is the same thing as the current at this position. They don't change. It's the same current. So whatever current is here is the same current that is here. Current does not change in a series circuit. It must be 8 volts over 200 plus 300, which is going to be equals to 1.455 milliamps. You can also use mesh analysis if you want. I already told you. Now next we're going to off the 8 volts. To off a voltage circuit, you have to short circuit it. So it's going to be, so now I've short the 8 volt circuit at this point. But see, a short circuit affects any element that's resistor, capacitor, whatever, that is directly in parallel with it. This is because voltage in a parallel circuit is the same. This voltage here is the same thing as the voltage here, which means if the voltage here has now become 0 volt because I short circuited it, whatever is in parallel with it, that resistor basically becomes useless. There's no voltage there to push any form of current there. So basically, this entire circuit is no longer needed. Yes, and this is just a wire. Now to find the current going through this position, this 5 milliamps, you're simply going to use CDR, that's current divider rule, because since this is a parallel circuit, when the current comes here to divide here and here, you can use current divider rule. So we want to find the currents that will come into this position now. So it's going to be 300 over 200 plus 300 times 5 milliamps, the total current. So CDR is like you take the opposite resistor of the one you're trying to find over the one you're trying to find plus that opposite resistor. So this is going to be IR1, I bar. It's not actually the main one. So it's I bar bar. Then equals to 3 milliamps. Now you're simply going to add them up together. So it's going to be I bar R1 plus I bar R1, which is equals to what? 4.455 milliamps. And this is the current for IR1. And just a note, I feel like someone might use mesh analysis. In mesh analysis, you're going to get that I1, that is your current that will be here, it will be equals to minus 1.455 milliamps. But notice how the I1 is going in this direction and the IR1 is going in this direction. That is, they're going in opposing directions. So it will mean that IR1 is equals to the negative of whatever I1 is because they're opposing, which means IR1 will still be equals to 1.455 milliamps. So in case you wanted to do mesh analysis, thank you for listening.